online video tutorial series of computer network subject. In this video, I will start a new unit of your computer network subject, that is unit number 3, transport layer. Transport layer is working in both the OSI and TCP/IP model. We are concentrating in your syllabus TCP/IP model. So transport layer is the second layer from the sender side. When the data is sending from the application layer, transport layer is receiving those data. Then after it will process and then it forward to the network layer. So what the transport layer is exactly processed for that particular data we are trying to understand in this unit. So let's start with the what are the particular transport layer services are provided and which particular data items are used in this unit. So in this unit we are trying to understand first basic principle behind the transport layer services. What the services are provided by this layer. In that, what the particular process are performed by the transport layer, that will be understand one by one. The first process is all about multiplexing and demultiplexing. Then the concept of reliable data transfer, flow control, congestion control. So these four characteristics are the identity of our transport layer. So we will understand all these characteristics in detail in the later part of our this unit. Next is the protocols. So each and every layer of our TCP/IP model is working on some standard protocols. So our transport layer is basically used two protocols, UDP, that is stands for user datagram protocol, and that provides the connection layer services, and the next one is TCP, that is used for a transmission control protocol, and it is used for connection oriented services. So we understand both the protocol with its packet formatting data. So this is the basic, the terminologies and the services that are provided by our transport layer. So let's move to our outline. What are the contents we are covering in this unit? So first is all about transport layer services. Which are the services are provided by transport layer? How the exactly transport layer is working in our particular model place with the real world example. Then after I will explain the multiplexing and demultiplexing concept. Then I will explain user datagram protocol, that is your UDP, that is connection layer protocol. Then after we will understand the concept of reliable data transfer concept. Then the concept of our TCP protocol, and then we understand the congestion protocol, what are the protocols are used to solve the congestion problem, and with the context of different algorithms. So let's start with our first topic, that is all about transport layer services. So let's see the one scenario. In that, number of devices are already seen in this particular figure. Number of hosts are available, routers are available, how the data is transferred, and how the transport layer is supporting this. So let's understand all this terminology one by one. So when we are talking about the transport layer services, it provides one logical communication between the number of processes running on your particular different host. So what's the processes are here? When you are surfing anything, when you are using your system, you already directly connected with your reference model, and that layer is your application layer. So when you are using any application that connected with any protocol, any application, that applications are also connected at the receiver side. So application layer is the topmost layer where the number of hosts are connected. So at a time, user can use multiple processes, or we can say that it use multiple application at a time. So how the user can connect with that application to application from host to host, that the logical communications are provided by our transport layer. This is the aim of our transport layer. How the user are connected logically with source to destination with the number of applications simultaneously, that is the concept of our transport layer. So how that will be provided? So it is divided into the two parts, server side concept and client side concept. So when the sender, the data is transferring from source to destination, how the data is performing the task. First, it takes the data from the application layer, and that particular messages are break into the smaller parts, and that parts are known as a segment here. That segments then after processed, and then it will send to the network layer. We already discussed about the network layer. Network layer uses the concept of fragment to send the data to the lower level. But when we are talking about transport layer is taking the data from the upper layer application layer, break that data to the smaller part, that is known as a segment, and then after it process and send to the particular lower level, that is your network layer. Now what the process are performed at the receiver side. Now at the receiver side, it takes the data from our network layer, because that is the bottom layer of your server side from the transport. It combines those data in the form of segment, and then after it will prepare one data and transfer to the upper layer, that is your application layer. So vice versa, both the side our particular transport layer is performing the task of segmentation and reassembly task. For that, it will use basically two protocols here that is used widely on internet, that is your TCP and UDP. So this is the basic idea how our particular data process is working here. So let's understand with this particular animation. Each and every host contains this protocol suite here. When the transport layer is connected, it creates one logical communication. That logical communication is performing the task of sending those segments from host to destination. Now we are seeing the task of transport versus network here. So when we are talking about the communication between two hosts here, when one source is there, one destination is there, and I want to create one logical path, then simple that path is performed by your network layer, because router is performing that task. But when we are talking about transport layer, it is all about the logical communication between two processes. So in particular host, number of processes are performing simultaneously. So how they are identically knowing each other from source to destination, that is all about your transport layer. But our transport layer relies on your network layer. It enhances the particular facility of your transport layer, and it also use the services of network layer. Now we are seeing this all the terminology with the real-time example. So let's understand. One group of children are moving during the vacation slot from one house to another house. The first is known as a west side, second is all about east side. Now how we are understanding this with our analogy? So here we can understand that two processes here, one is your host at west side, another is east side. So we can say that it is your AND systems. So AND systems, or we can host, that will be known as here as a house here. Next is how we are containing what are the processes are performed here. The children, we are moving from one place to another place, so we can say that they are processes here. Now how the particular transport layer and network layer is performing some specific tasks. Now this children wants to share these some messages in the form of letter. So what the process is performing here? Children is writing the letter. That letter is posted by one postal services, and then they are transferring that data from source to destination, that means one house to another house. So where the transport layer and network layer is performing the task here. So for that we require some person to transfer the data, and one service is available, that is your postal service. So here application messages here application messages, number of messages, so number of letters are here. So number of letters in the envelope, it is all, we can say that it is our application messages. And here network layer protocols. So how the network layer is performing here? So when we are saying that our message is transferring by the postal services from source to destination, they only knowing the route here, and they knowing the host. They are not knowing what the letter is here and for which letter is identical. So that is the difference. When we are talking about network layer is only knowing source to destination only. So that knowing the west side house and south side, east side house, and it create one logical link to transfer the data. That is the our postal service. So when we are sending data from one end to another end, that will be supported by our network layer. But when we are talking about transport layer is saying that all about what is the process is done by here. So NNBL is the cousin, they are transferring the data, that is the process we are performing here. That is the known as a transport layer service. Now we are moving to this particular internet transport layer protocols services. So when we are talking about TCP here, so TCP also is all about reliable data transfer. In order, it provides the in order delivery. In which order you are transferring the data, in the same order receiver is receiving the data. It's also provide the congestion control, flow control. Now, how the particular data is sending to the particular receiver? For that, it establishes one connection. So for reliable delivery, we are performing the handshaking process. So here connection setup is also performing by our TCP. When we are talking about the UDP here, so UDP is all about unreliable data services. So we can say that when we are sending the data with the help of UDP, the order is not maintaining here, but the receiver side it is received those data and reassemble and user is getting the data. But we can say also that it is not a guaranteed data delivery service also. So we can say that we are not providing delay guarantee also and bandwidth guarantee also. So this is the basic idea how the internet is working using this particular protocol. Now we are moving to our particular next protocol or services, that is all about multiplexing and demultiplexing. So when we are talking about the multiplexing and demultiplexing, we have to understand some terminologies. First is IP address and another is port number. So when we are talking about IP address, we already briefly discussed MAC address, IP address in our network layer. So IP address is all about unique identification of your host in your particular network. So when we are talking about the process or port number, then it identifies the unique applications running on your machine. Suppose 3 applications are right now working on your machine. So each and every process are identical one port number that uniquely identified for your machine, and also request for that same application are go through that particular port number. So multiplexing at the what happened at the sender side. So here handle the data from the multiple sockets. So here keyword is all about socket. Socket is one plug and play like thing. When your data is transferring from source to destination, one common point is there, from that your data is going, and that common point is unique for that particular port number. So it handles the data from the multiple sockets and add transport layer header. So here header of your transport layer is used for that particular process, and the same header is used at the receiver side. What the receiver side is performing, the same header is used for the purpose of the demultiplexing. So for which particular socket data is sending at the receiver side, it open the envelope, check this particular header thing and demultiplex that particular side. So in particular figure you can see how the process is performing. At the application layer we can see that process 3, process 1, process 2 and process 4 is available. In the yellow highlighted particular portion we can say that it is all about socket, and blue highlighted line is all about our processes. So when the particular process want to execute, so for each and every process one socket is created. So we can see here process for P1 we have created one socket, for process P2 we also created one unique socket. Now P1 wants to communicate with this particular machine, so it creates one logical communication. At P3 it also creates one socket here. So both the sockets are uniquely identified because each and every machine is having simultaneously it can work on the number of processes. The same way P2 can be communicated with this particular P4 here. So for multiplexing and demultiplexing we have to understand both these terminals. Now understand how the multiplexing and demultiplexing working in TCP and UDP. So let's understand how the demultiplexing is work here. So when the particular user wants to send the data, it requires some particular unique thing of their network. So that is all about source port number and destination port number, because we already know the IP addresses of that particular machines. But after reaching the IP address, we have to identify which port is identically we are particular targeting here. Okay, suppose you are targeting X application here. So after reaching to the particular destination, you have to say that I am coming from that particular machine, that is IP address, but I want to communicate with this process only. So that process is identified by our socket and port number here. So this is the all about the source port address and destination port number. So each and every datagram have a unique source IP address and destination IP address. And each datagram carries one transport layer segment, that is our message, and each segment having the source and destination port number. So whenever that particular message is going through the particular our network, it carries the IP as well as port number. So for transport layer services, to transfer the data from source to destination, we required IP address as well as port number here. Then and then we can appropriately send the data to the particular dedicated socket. So in connection-less service, how I can create the particular data item? So for that, practically we are using datagram socket class. Okay, in the datagram socket class, we are passing the as a parameter port number. So in UDP, we have to understand that we only require the port number here, because we already know what the particular destination is there. So destination is already we know for which destination I am targeting this particular process. So for that I have to choose one particular port of the destination, and then I have to request that. So after creating my datagram, we must understand what is my destination address and destination port number. Without this port number, we cannot send those data. When the host receives the UDP segment, it checks the destination port first. For which particular port my sender is sending the data, because at that time this receiver having multiple processes are working. So it will check the port number. If that port number matches the found, then it will process and then it will give the reward. So IP datagram with the same destination port number but with the different source IP address, if addresses or port number will be redirected to another one. So this is the basic idea how the connection-less demultiplexing is working. All the scenarios are shown by this particular figure. So application P1, P3 and P4. Three different processes are for different three hosts here. So if P1 wants to send the data to particular P3, so which basic requirement is that? So for that we can see here source port number. So source port number is all about our P1 port number, that is our 6428. Here destination is all about this particular device A. For that destination port number is 9157. So when we are creating the socket, we are by default giving this particular port number. So this A application having port number 9157, 2 having 6423 and 3 having 5775. So when P1 wants to send the data to P2 or P2 or P3 or P3 and P4 here, so it must set the source port number as well as destination port number. So here we can see here when P3 wants to send the data to P4, what happened here? Source port number is 9157 and destination is 6428. So 642 is all about here given particular P1. So this is the basic idea how the connection-less demultiplexing is working. Now we are talking about the connection-oriented demultiplexing. So when we are talking about connection-oriented, so here reliability is there. What happened in the previous one, connection-less? No reliability, no guaranteed data is transferring. But when we are talking about connection-oriented, when some surety is there, reliability is there. So at that time we need minimum 4 tuples here. That is source IP, source port number, destination IP, destination port number. When we are talking about connection-oriented, we only require the port number here. IP and port both are used. So when TCP segment arrives, receiver use all four values, where in UDP we are using only single values. Okay, so server host may support simultaneously TCP socket here, because we have to match all four parameters for our system, for the receiver system. If it is found, then it responds, otherwise it is rejected there. So according to the HTTP version, we are finding this the same value. Let's understand this topic with this next figure. Okay, so here my application, we having P4, P5 and P6. Three applications are working right now in this machine. Here application A having P3 process, and application 2 having P2 and P3 process. Now we want to communicate with this. Suppose P4 wants to communicate with P3. So what are the requirements are here? So here we need first IP address. So what is the source IP address and what is the destination IP address? So here this machine is having server IP address B, and this is the IP address of A. So first requirement is all about source and destination IP address, and second requirement is port number. So when I am sending the request, I need to send source IP address and source port number. So we can see here my source IP address is given and particular port number is given. So the same way, when we want to communicate with application with different process, the same process will be done. If we can see that P6 wants to communicate with P2, so it also check the IP addresses, that is all about source, and that is the all about destination. And next it will check the port number for what, port number for which process we are performing or we are requesting this particular data item. So this is the basic idea how the connection oriented demultiplexing is working. Thank you for watching this video. In next video, I will explain about the how the UDP and TCP protocol is working in our transport layer.